5-pole transfer switches employed in scenarios that necessitate transitioning between two distinct power sources, frequently a utility grid and a generator. The defining characteristic of a 5-pole transfer switch lies in its ability to switch not only the 3 phases or 2 phases, depending on the voltage and the ground, but also the neutral conductor. This is the crucial difference from a standard 4-pole transfer switch. The necessity of switching the neutral arises from several potential issues that can occur when the neutral is not switched. Firstly, ground loops. If the neutral from both the utility and the generator are connected together, it can create a ground loop. A ground loop is a condition where multiple paths to ground exist, creating the possibility for unwanted current to flow through the grounding conductors. These circulating currents can induce noise in sensitive electronic equipment and, in extreme cases, pose a shock hazard. Secondly, voltage imbalances. In systems where the loads are not perfectly balanced, a shared neutral can lead to voltage imbalances. When the generator is supplying power, current flowing through the shared neutral impedance can cause different voltage drops on each phase, affecting the performance of connected equipment. Thirdly, sensitive equipment. Certain sensitive electronic equipment may be susceptible to interference or damage if the neutral is not properly isolated between the two power sources. The 5-pole transfer switch ensures that the neutral from only one source is connected at any given time, preventing any potential issues. When selecting a 5-pole transfer switch, it is important to consider the following factors. Firstly, ampacity. The switch must be rated to handle the full load current of the circuit it is switching. In the case of a 200 amp service, the switch must have a minimum rating of 200 amps. Secondly, voltage. The voltage rating of the switch must match the system voltage, such as 240 volts. Thirdly, number of poles. Ensure that the switch has the correct number of poles for the application. For single-phase 120 or 240 volt systems, 5 poles are needed for switching both hot legs, the neutral, and the ground. For 3-phase 208, 240, or 480 volt systems, 5 poles are needed for switching all 3 phases, the neutral and the ground. Fourthly, switching mechanism. Transfer switches are available with manual and automatic switching mechanisms. Manual switches require the user to physically switch between power sources, while automatic switches detect power outages and automatically switch to the backup power source. Automatic transfer switches offer convenience and ensure a seamless transition during power outages. Fifthly, certifications. Look for transfer switches that are certified by recognized testing laboratories such as Underwriters Laboratories or all to ensure that they meet safety standards. Installation of a 5-pole transfer switch should always be performed by a qualified electrician in accordance with all applicable electrical codes. Proper wiring and grounding techniques are essential for safe and reliable operation. Before installing a 5-pole transfer switch, it's crucial to understand the specific application and local electrical codes. Firstly, identify the load requirements. Determine the total current draw of the circuits that will be powered by the transfer switch. This will help you select a switch with the appropriate ampacity rating. Secondly, understand the wiring configuration. Familiarize yourself with the wiring configuration of the electrical panel and the generator. This includes identifying the hot legs, neutral, and ground connections. Thirdly, review local electrical codes. Consult the local electrical codes and regulations to ensure that the installation complies with all requirements. This may include specific grounding requirements or restrictions on the types of transfer switches that can be used. The installation process typically involves the following steps. Firstly, disconnect power. Turn off the main breaker in the electrical panel to disconnect power to the circuits that will be connected to the transfer switch. Secondly, mount the transfer switch. Mount the transfer switch in a suitable location, typically near the electrical panel. Ensure that the switch is securely mounted and easily accessible. Thirdly, wire the transfer switch. Connect the wires from the electrical panel and the generator to the appropriate terminals on the transfer switch. Follow the wiring diagram provided with the switch and ensure that all connections are tight. Fourthly, ground the transfer switch. Connect the ground wire from the electrical panel to the grounding terminal on the transfer switch. This ensures that the switch is properly grounded and protected against electrical faults. Fifthly, test the installation. After the installation is complete, test the transfer switch to ensure that it is working properly. This includes verifying that the switch switches between power sources correctly and that all circuits are powered as expected. Some additional considerations include, firstly, generator compatibility. Ensure that the generator is compatible with the transfer switch. This includes verifying that the generator has the correct voltage and frequency output and that it is equipped with the necessary connections for the transfer switch. Secondly, load management. Consider load management strategies to prevent overloading the generator. This may involve shedding non-essential loads during a power outage to reduce the total current draw on the generator. Thirdly, maintenance. Regularly inspect and maintain the transfer switch to ensure that it is in good working condition. This includes checking the wiring connections, cleaning the switch, and testing the switching mechanism. Failure to switch the neutral can lead to several problems. Firstly, circulating neutral currents can occur if the neutral conductors of the two power sources are connected together. This can cause overheating of the neutral conductors and create a potential fire hazard. Secondly, voltage imbalances can occur if the loads are not evenly distributed between the phases. This can damage sensitive electronic equipment. Thirdly, ground faults can occur if there is a fault in the wiring. This can create a shock hazard. A 5-pole transfer switch is often used with generators. When using a generator as a backup power source, it is important to ensure that the generator is properly sized to handle the load. Overloading the generator can damage the generator and create a potential fire hazard. Additionally, it is important to ensure that the generator is properly grounded. Improper grounding can create a shock hazard. There are different types of 5-pole transfer switches. Firstly, manual transfer switches. Manual transfer switches require the user to manually switch between the two power sources. These switches are typically less expensive than automatic transfer switches, but they require the user to be present to switch between power sources. Secondly, automatic transfer switches. Automatic transfer switches automatically switch between the two power sources when a power outage occurs. These switches are more expensive than manual transfer switches, but they offer the convenience of automatically switching to the backup power source without any user intervention. When choosing a 5-pole transfer switch, it is important to consider the following factors. Firstly, the ampacity rating of the switch. The ampacity rating of the switch must be greater than or equal to the maximum current that will flow through the switch. Secondly, the voltage rating of the switch. The voltage rating of the switch must be greater than or equal to the maximum voltage that will be present in the switch. Thirdly, the number of poles. The switch must have the correct number of poles for the application. Fourthly, the type of switch. The switch can be either a manual transfer switch or an automatic transfer switch. Fifthly, the price of the switch. The price of the switch can vary depending on the ampacity rating, voltage rating, number of poles, and type of switch. In summary, a 5-pole transfer switch is a specialized type of transfer switch used to switch between two power sources, including the neutral conductor. It is essential for applications where ground loops, voltage imbalances, or sensitive equipment may be affected by a shared neutral. When selecting and installing a 5-pole transfer switch, it is important to consider factors such as ampacity, voltage, number of poles, switching mechanism, certifications, and local electrical codes. Proper installation and maintenance are crucial for safe and reliable operation.